Okay, someone started the recording. Fine. Let me know once you guys can see my screen. Can you guys see my screen?
Yes.
Okay, so any doubts so far, whatever we have discussed? Okay, I consider that as a no. So now tell me what are the types of frames which we have discussed so far?
Data frame and remote frame.
Data frame and remote frame. Okay, then that's it.
Error frame.
Sorry.
Error frame.
Very good. Still there are 3 errors to discuss.
Overload frame.
Very good.
Data frame space.
Yes, very good. Okay, so I hope this is clear. So moving on. Hmm, okay. So I told I will give few scenarios to understand how much you guys have understood the arbitralization. Okay, so one point before, okay, I'll tell the point once after you guys tell the answer. Let's see, because nobody has asked that question for me. Okay, so let's say there are two ECUs which are connected to the bus network, ECU A and ECU B. So ECU A sends a frame with the identifier 173 data, and ECU B also sends the frame with the identifier 175 with the data at a time. Okay. So what happens if both the ECUs are sending the frames at a time with the identifier 170 and 175? Do you think the CAN protocol bus will be considered both since it is sending at a time?
Yeah, yes.
No, that's what is the thing which I want to explain here. So everything is a bit by bit only happens. So all the electronic this is a serial protocol where it consider it sends one particular data at a time and receive one data at a time, nothing but one bit at a time. It cannot send multiple bits at a time. Okay, it's a serial protocol, and I hope you guys are already discussed asynchronous and serial protocol while in the previous classes with the other sessions. Okay, so here since you guys have discussed the SPI I2C everything, right? Hello, hello, am I audible?
Yeah.
Yeah, what I am asking, what is asynchronous and serial protocol meaning? What is serial protocol meaning, and what is asynchronous meaning? Nobody knows. So did you guys discuss the I2C protocol and the SPI protocol before?
Serial communication is the process of sending data one bit at a time.
Very good. So CAN protocol is a serial protocol. So now tell me what happens when the ECU is sending 173 frame with the identifier 173, and ECU B is sending the frame with the identifier 175 at a time.
It will match the overload frame.
Only for 2 frames? Okay, so the
And
concept here is the overload frames coming to picture when there is a many like 1,000, 10,000, or 1 lakh frames in on the bus. That time only bus is going to say, I'm overloaded, I'm exhausted, I cannot consider your frame. So the thing is, whenever the ECU is multiple ECU is trying to send the messages at a time with the different identifiers, it is like a kind of what is happening here, conflicting. Even ECU A is sending the data, ECU B is sending the data, like that 100 ECUs will be sending the data at a time. So what happens, that's where the arbitrarization comes into picture. Okay, so wherever why exactly we have this identifier? So it is to identify the input also, and it is used to identify the priority also. So lower the priority gets the lower the ID gets the higher priority. So what happens in the ECU A, ECU B sending the frame with the identifier 173, 175 at the same time. So in the as per the arbitralization, it is a bit arbitralization. What happens? Let me write down 173. 1 means 00001. 7 means 0. Yes, please guys, I'm expecting you guys to tell. 111. So 3 means 0011.
One.
Similarly, let me write 175. 0001. 7 is same. And 5 means 0101. So now arbitralization meaning what? So every bit by bit is it will be like considered. So here we have the nothing but the frame is transferring nothing but this is how it is transferring. This is the 173, this is the 175. After that DLC, after that like it goes. It's in a binary form. As someone said, serial communication is we can send one bit at a time. Correct, right? So whatever will be received by the ECU, so the bus will be has to prioritize the between the 173 and 175. It cannot process both. It can process only one frame, that too bit by bit. So now dominant, 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 recessive, recessive. So dominant, recessive, because 170 full it's same. So now let's go to the 3 and 5. I will write down 3, write down 5. So now tells me who wins the arbitralization.
Mm,
Three.
Very good. 3, which is 173 wins the arbitrization over the 175. Always lower the identifier wins the arbitrization over the high, big number of identifier. Clear? This is what the second purpose of identifier.
okay.
Understood? So now assume there are 100 ECUs which are sending the data with the hundreds of identifiers. So every IDs will be every data will be compared like this. This is called a arbitrization. Who wins the priority over the 100 frames? Only one only one frame can get the arbitrization. Nothing but wins the arbitrization, not every 100. So once one frame wins the arbitrization, other frame will be ignored, and once it is processed, again this will be sent automatically. So that is the reason we the next one whatever is goes it will be on the queue. And if another 10 100 100 ECUs are sending the messages, it will be on the queue. Whoever winning the arbitrization will be processed. Other than that, all the frames will be ignored and will be resent by the ECUs and will be keep on in queue. That is where the bus load comes into picture. Okay, so when the bus is getting loaded so much, it will send a overload message stating, I am exhausted, I cannot accept your message. So it is clear?
Yeah.
Okay, so now I will give the next scenario which I have already explained and I want you guys to tell me. Anyway, these are the kind of interview questions which I used to teach for my students. But anyway, for you guys, other someone will clear the interview, but you don't need all these things. But it's good to know because it will be helpful once you start giving the interviews after completion of 2 to 3 years. That because all these things you are not going to learn in the job. Okay, all these things is like a self learn which you have to do by yourself. So ECU A is configured with the extended identifier, ECU B is configured with the standard identifier, and extended identifier some data identifier with the 14 DA 59 F1. Standard identifier is just 173. So now these two ECUs are sending the data at a time. Who wins the arbitralization?
ECUB.
Can you tell me extended or standard? I mean, I didn't write ARB, so
Yeah,
Standard.
extended. In extended, there will be XSR. Standard.
sorry.
Standard.
Standard one. Standard one.
Yes, standard wins the arbitration. Because of what? Why it wins the arbitration?
Because of dominant.
Dominant of what?
Arbitrary.
Identify.
Okay. Like in our case, once after the 11-bit identifier, here only it wins the orbit. Like, you see 14D, and it is 14D, is it less than the 173? You can check if it is, even though if it is less, what happens? Why we have the SRR bit, which will be always recessive. In that bit, because of this particular bit, which is always recessive in the extended identifier, the standard identifier wins the arbitralization. Clear? Or any doubt? Okay. So now tell me, we have discussed errors also, two types of errors. But anyway, I'll ask this question. Just assume I have only one node. I have only one node connected on the network, bus network. What is the behavior you would like to, what is the behavior do you think what happens here? There is only one node connected to the bus. And this node is sending the data on the bus. So what is the behavior you think will happen?
There are no other ECUs.
No, there are no other
Yes.
ECUs. There is only one ECU. What is the behavior do you see? If same thing you consider in your project, you have created one of the CAN node, or in your software you are considering only one node which is sending the data. So what happens? What do you like? What do you expect from? What is the behavior you expect?
Acknowledgement error.
Very good. It provides the acknowledgement error because there are no ECUs to acknowledge for this particular frame which is sent by this particular ECU. Very good. So this is all about few of the scenarios, but like this we have many. So if you are completely going to work as a tester on, especially on the CAN, you need to have all this information, nothing but all this knowledge to work. Okay, so moving on.
Okay, so
Mhm.
one bus has to have a minimum of two ECUs, right?
It can have multiple. It depends on, in practically, we can connect based on the capacity of the bus. We can connect 80 nodes, 90 nodes based on the capacity of the bus. Okay, so in the project, when you comes to the project, you work on only on one system. Okay, so you will be testing or developing anything only for one ECU, not for multiple ECU. Other ECU you will be virtually create the scenarios by using Kenoi. Nothing but you will create the virtual nodes. Getting?
Yeah, yeah, getting. Okay.
Yeah, that's how it is. Because in the project you will be working on only one ECU. If you are working on airbag, you will work on airbag ECU, not on any other ECU. If you are working on brake ECU, you will be working on only one ECU, which is a brake ECU. So all other inputs which is required for the brake ECU will be created virtually, virtual nodes by using the Kenoi. I will show that Kenoi also how it is done, because that is what is important. So when you get in the job, that is what you will see, Kenoi. Okay. So
So
in the
can and cannot is different, right?
sorry.
Can and cannot is different or same?
CAN is a protocol, CANOE is a hardware. So
Okay.
CAN protocol will be like whatever we are discussing the protocol, it should have something like to work out nothing but you have the protocol, you know how it is working, but you cannot test everything in the vehicle because every scenario if you are going to test in the vehicle it is not possible because every time for every test cases you will be how much petrol you need, how much fuel you need, so it is difficult. Okay, so that is the reason we have a virtual environment which will be created by the CANOE. CANOE supports all the protocols, not only CAN protocols, CAN-FD, MOST, LexRay, LIN, any protocol it will support. But that is the vector tool which we use for to create the environment, virtual car environment, not the complete car. It is just your system. If you are working on brake system, just it will allow you to create the brake system inputs, and your output is brake ECU, the real ECU will be using.
Yeah, fine.
Got it?
Yeah, got it.
Okay, so moving on to the error frames, we have already discussed CRC error and the acknowledgement error. So, and the three which we have left out is foam error, stuff error, bit stuff error. So let me explain the foam error. It is bit easy. So you will be seeing all these errors very frequently whenever you are executing or whenever you are testing or whenever you are developing. Of course, if you are developing means you have to test it to make sure that you have developed right way. Otherwise, it is not allowed to get into the next process at all. So that is the purpose you will be testing it. That time you will see this error, CRC error will be keep on sending on the bus, acknowledgement error will be keep on sending on the bus. So you should be able to clear those errors. So for that purpose you should know what is this errors. So when it comes to the form error, form okay, let me go to the above, easy for me to explain. Okay, so as you can see here, end of the frame is having a 7 bits of recessive. It is a fixed end of the frame field should have the 7 bits of size with the default values of recessive 1 1 1 1 1, and intermission interspace also should have the 3 bits, 3 bits of size with the value 1 1 1, which is always recessive. And suppose if this particular field is getting updated with the another value. What is another value we have in binary except recessive? It is dominant. If any illegal bits, nothing but it is already fixed. But in any of the case, if it is getting changed, then ECU will be responding with the form error. Okay, so and I said I will be explaining why we are having the acknowledgement delimiter. Acknowledgement delimiter is used to identify this form error. This is a one bit of size. Okay, and the CRC delimiter is used to store the whether when the CRC is matched, of course there is no error. When the CRC is mismatched, of course it creates the CRC error. So that information, like whether it is a matched or not matched, that will be to check whether the CRC completion successful or unsuccessful, I can say. That will be storing in the CRC delimiter, which is having one size, one bit size. Okay, so form error is simple where the fixed format of the EC, like the CAN frame, where we have on the end of the frame and the intermission space, we have the overall 10 bits of size will be filled with the recessive 1 1 1 1 1 1. If any one bit changes to dominant, then ECU will not communicate. It will provide the error which is form error. Clear?
Yeah.
Okay. So the next error is bit error. Then we will go for the bit stuffing. Bit stuffing is little bit important. So please try to understand. Where is that? Huh. So the next is bit error. Bit error is simple. Let me just open here. Yeah. So assume ECU A has transmitted some data like 0 1 1 0 1 0 1 0, and it is supposed to be accepted by the ECU B. Okay. So now ECU B as like received the 0, received 1, but when it comes to this bit, it has received recessive, not the dominant, and recessive it has received, and dominant, recessive, and dominant. It is received everything properly, but this particular dominant bit, ECU B didn't receive that as a dominant, but it has received as a recessive. So what does it mean? It's not the proper data which has been received by the ECU-B. Nothing but ECU-B didn't receive the data which has been transmitted by the ECU-A. So what is the problem here? The bit is the problem. The whatever has been sent is the dominant, but whatever has been received by the ECU-B is a recessive. So this is the error. We call it as bit error. Understood?
Yeah.
Okay, so the one is last one is bit stuffing error. To understand bit stuffing error, we have to little bit discuss more about the synchronization. So why exactly we have this bit stuffing error? So we will understand that first. So first of all, anybody knows what is synchronization? In generally, I'm not asking about the CAN. So in general, what is synchronization?
Moving together.
Mm-hmm. Together. Okay.
Same time and or same rate, ma'am.
Very
Same
good.
time.
So, what is like, the synchronization, it's syncing with the something which is like it comes along with the time. Nothing but if I whatever I'm explaining, if I go too fast, you will not understand. If I go too slow, you will feel bored. So I should maintain one like the what I can say, it's kind of a limit what I have to maintain to make you guys listen to me. Correct, right? So similarly, what happens? How many ECUs we have connected on the bus? Anyway, in your project, you will be connecting real ECU is one, and another everything every ECU will be virtual. But in practically, you will be connecting many more ECUs. Okay, based on the capacity of the bus. So let's say how and one concept to explain here. Now ECU A is sending the data on the bus. Whatever the data has been transmitted, it will be received by the every ECU. It will not ignored by any ECU initially. It will be received by the every ECU, or it will not be received by the any of the ECU which is connected to the bus. Okay, so now what happens? ECU sending the data on the bus, and it has won the arbitralization, and it has transmitted to the every ECU. So ECU B checks whether it is applicable for me. So if it is not applicable, it will not accept. It will just ignore this frame. So it will go to the next. I mean, it will not go to the next. It will go. It will be received by the every ECU. So ECUC will check whether this input is required for me or not. If it is not required, then it will not accept. If now ECUD, it will just ignore the data. ECUC will ignore the data. So now it will come to the ECUD. So ECUD requires that input, so it will accept that particular frame. ECUE, it does not require that input, it will not accept that information. This is how it is. Every frame, whatever has been transmitted to the bus, will be received by the every ECU which is connected to the bus network, or it will not received by the single ECU which is connected to the bus. So then how exactly this is happening? The checking. For that, I would like to open another PPT. So this is how it checks. So how we have discussed the hardware level of CAN transceiver, CAN controller, microcontroller will be present in the name of when we say an ECU. So when it comes to the software part, this is how it will be. So the first is a RX buffer, TX buffer, acceptance checking, send and receive. This is where the acceptance checking will be done. If this particular ECU in the acceptance checking, if this ECU requires the input whatever has been transmitted on the bus, it will accept that input or information. If not, it will just ignore the data. Understood? This is like a software. This is how the once you get in for the development, you will understand. You will be creating the buffers, and this is a one of the function. When we say the acceptance checking, it is a kind of a function. The if you are handling one ECU, this ECU should accept only these many IDs. Otherwise, it should ignore. That is what you will write a code. That is what is happens in the bus. Clear?
Yeah.
Okay. So moving on. Okay. I came here to explain another concept, right? Okay. For the synchronization. Yeah. So this is how the first concept is. So what does it mean about the synchronization? As she said, so to accept the message by the every ECU which are connected to the network, once the message come to the bus, then every ECU should be in a sync. What does it mean in a sync? Every ECU should be active at that time. Then only it can accept the data. Otherwise, of course, it will not be active and it cannot accept the data. So to maintain every ECUs to be sync as per the every ECU to be in sync as per the bus network. That is the purpose what we have to maintain to make every ECU in the sync. What happens if okay, let me put it in this way. So what happens if I keep on explaining for 3 hours, you will go to sleep, correct, right?
Yeah. Most probably.
Yeah, right.
Yes. So what happens? It's same. It's similar case in the ECU also. What happens if you keep on sending the recessive bits? It will go to the sleep mode. So to make it active, what we need to do? We have to trigger a dominant. Okay. So how we will be triggering a dominant? So if assume the ECU A is sending the data with the the data itself is like a everything is in a recessive kind of like one like this. If it is sending, then it will be like completely it's a recessive. Nothing but what is happening with the wires? There is no voltage fluctuation. It is always like this. There is no fluctuation. It is always like this. What does it mean like this? You guys would have seen in the movies. If someone is dying, the wave will go straight line. Nothing but there is no pulse. What does it mean by pulse?
Recessive.
Dominant recessive. This is
Mhm.
called pulse. If it's simply like this, it's nothing but it's dead. Nothing but it's
That
there is no fluctuation. So what happens if
inactive
it is
state.
correct inactive state? So what happens if the some ECU is sending only the recessive, nothing but like this? What happens? Like only one recessive. So ECU will not be in sync. Nothing but ECU will go to sleep mode. Okay, every ECU will not be in sync. So what we have to do for that purpose? What we have to do for to make the pulse or to create the fluctuation? What we have to do?
Condition
Bring it
down.
down.
Dominant. So we should create the fluctuation. Instead of always having this, we have to come down, nothing but a dominant. And then you can go for recessive. But again, it keeps on going in its inactive state. That is the reason you have to come down, nothing but a dominant. Then you can go ahead. Correct, right? This is so that is what is we are doing in the bit stuffing. Bit stuffing is used to maintain the synchronization. So how are we maintaining the synchronization? As per the standard says, if we are sending the 5 bits of the same polarity, recessive, 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 3, 2, 5. If you are sending the same polarity of the same data, then it will lead to the, what I can say, the ECUs will not be in sync, nothing but an inactive state. To make this to be in sync, we will stuff the opposite polarity of this 5 consecutive bits. Okay, and then it will go ahead with the data. If it is as 3 of recessive, fine, and then it has dominant, fine, and then it is having, let's assume it is having the dominant, 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 and then dominant. So do you think we need to stuff the recessive bit or not here?
Yeah, it will stop it.
Sorry.
Yeah, it will stop dominant and again it will send the recessive.
Very good. So it is irrespective of the recessive or dominant bit, it is about the polarity. It should not be in the same state for long time. What does that mean? There is no voltage fluctuation for long time, which will leads to the inactive state. That is the reason whenever we have the 5 consecutive bits with the same polarity, we have to, not we, it is a CAN transceiver job. Okay, one job of CAN transceiver is to convert the voltage into the binary and binary to the voltage. And also it will perform the bit stuffing, where if there is any continuous 5 consecutive bits with the same polarity, it will stuff the opposite polarity of the bit. Okay, this is what is bit stuffing. Then what is bit stuffing error means? If this is not happening, it is, the ECU didn't stuff, the CAN transceiver didn't stuff the opposite polarity before, I mean after having the 5 consecutive bits with the same polarity. So that time what will do, what is the expectation?
Some bit stuff error.
Very good. It's a bit stuff error. So understood why are we doing the bit stuffing? To maintain the ECUs in the synchronization. And what is why exactly we are stuffing? Again for the synchronization purpose. And who will be doing it? CAN transfer will be doing it. If it is not done, then that is called a bit stuffing error, which will be sent by the receiver. That bit stuffing is not done. So clear?
Yeah.
Bit stuffing? Okay. So just for you, just to confirm you to provide the more clarity. I think there is one bit stuffing. There is arbitralization, acknowledgement, arbitralization. Again, acknowledgement. Oh, I had one. I think I have deleted it. Okay. Anyway, it's understandable. Adding stuffing of the opposite polarity. Okay. Okay, fine. Okay, so now, as of now, we have seen all the faults, nothing but all the errors. So now let's say what is exactly happens when your, acknowledgement fault, any one of the fault is flowing on the bus. Let me connect to my Kenoe so that I can show in practically. So instead of trying to explain in theory. Can you guys hear me? Hello?
Yeah, we can.
Yes.
Okay. Give me 2 minutes. I'm just trying to connect to the remote so that I can just simply show practically instead of explaining theoretically. This is what is called Kenoe software. Okay, and I can share you the pic how the Kenoe. Okay, I can anyway use the internet to show how the Kenoe hardware looks like. This is how it looks. This is a two-channel Kenoe which is present in the my hill setup, and this is the DB9 connector which we use to connect for this connector and the USB to the laptop. So this is a hardware. So if I have the hardware, how can I handle that with the, of course, the software. So for that software, this is what is the software. Kenoe 10.0 I'm using right now. Okay. Let me just keep one of the testing. Okay. So now let me go to the Kenoe. I'll just run it. So this is the channel. So I have showed you, right? Two channels are present. So in that two channel, which channel you have connected. So some of the project you will be using both the channels based on the project. So in our project, we need only one channel. So I have connected to the channel one, and in the hill setup I have connected to the CAN one. That is the reason I say okay. Can you see the error? Now you will see properly. This is how the error goes on. When there is an error on the bus, so all other ECUs, let me write down. So now assume there is an error. One error which is a acknowledgement error on the bus. Okay. So if the acknowledgement error, the error is transferring on the bus, other ECUs cannot communicate because the bus is filled with the active error. The acknowledgement error is, keep on sending from one of the ECU, then the bus is completely error. It is not error free. So it will not allow you to, accept, it will not does the arbitration, and it will not accept the communication between the other ECUs. Nothing but first of all, if it is not doing the arbitration, then of course it will not be sent. Okay, so now this is the error which is on the bus. It is called a active error, and it will not allow the other ECUs to communicate until unless ECU complete this network becomes error free. So that time what happens? What do you think would create the problem? See here it is completely error. So it is not allow. I mean, I'm not getting any output from the ECU now. Okay, so nothing but ECU is not communicating. Let's wait for the ECU to communicate then. So now can you see? Let me just pause it. Yeah. So now you can see here, I'll just take one example which is little bit easy for you to understand. Okay, anyway, CRC check is here. I can explain this. Dark failure is not required. Okay, see, this is one of the frame. Okay, so what is RX and TX? What do you think? What is RX and TX?
Receiver and transmitter.
Yes. So So now one concept I need to confirm you guys, because once after you get in that get into the job, then you should not be confused. Whatever the output from the ECU will be sent on the bus is called TX, nothing but transmission message. Okay. That time what happens, ECU is behaving like a transmitter. As we know in the first class itself, we know ECU acts as a transmitter and also receiver. When the ECU is transmitting the output, that is called a TX message. When the ECU is receiving the input, that is called RX message. Clear?
Yeah, clear.
Yeah. So now, but what happens in the Kenoi? The Kenoi is a virtual environment. You have only one real ECU. All other ECUs are virtual. Okay. So you virtual ECU, whatever you have created, these ECUs will be sending the data on the bus and will be received by the ECU, which is a real ECU. And okay, so what happens in the Kenoi in the virtual environment, the real ECU whatever has transmit, providing the output, that is considered as RX, and whatever it's, it is received by the other ECU is considered as a TX, because it is a output from the virtual ECUs. Okay, and this ECU will be outputting, that is in the direction of RX to the bus. This is opposite in the Kenoi environment because it is a virtual. In practically, this is what the meaning of TX and RX messages. I am explaining this because you will be having a one module as a CAN TX and RX messages. Even though you are a developer or a tester, you have to configure the TX and RX messages in the application layer. Even though you are a tester, you have to test TX and RX messages. That time you should not be confused. Okay, so this is the concept. The opposite concept will be applicable in the Kenoi virtual environment. Okay, as you can see here, here you can see the direction. The direction is Rx. What does it mean? This is the output from the ECU since it is a Kenoi configuration. In reality, nothing but in your module, all these are written as TX messages because these are all output from the real ECU in practically in the vehicle. Clear?
Yeah, clear.
Okay. So what else I need to show here? Okay, so as we were talking about the, like this is what you, even though you are a developer or the tester, you will be seeing only application layer, which is what is the DLC and what is the data. Nothing but this is the data field which contains the actual data, and this is the DLC. Except this, you might see the CRC verification, like every like by considering all the bits which has been transmitted, the CRC will be calculating and it will be comparing, and that will be providing here. CRC check you will be checking. Okay, this is what you will see in the application layer. Other than this, only tester can see the physical layer because they will be doing the physical testing. Otherwise, if you are going to be a CAN developer, then only you will get to see the complete what I can say physical layer of the CAN. Otherwise, you will be working on only application layer, not on the physical layer, not even on the data link layer. It depends on the job which you have got into. Okay. Uh, so any doubts so far?
No.
Okay, let me just stop this. So I'll just disconnect the Conti network. So 2 minutes, you may not be able to hear me. Just please wait. Okay, so can you guys able to hear me now?
Yeah.
Yes, ma'am.
Okay, it's recording. Fine. So we have seen an error which is we already discussed a active error. So when there is a active error, what is happening? It is not allowing other ECUs to communicate. So which will leads to the problem. Assume because of one issue, small issue, and there is an error with the one ECU, and all other ECUs which are connected to the network, if it is not communicating, then how exactly we are going to have the reliable system? Nothing but a car with the autonomous L5. It is not possible, right? So that is the purpose we have the counters. Every ECU will be having a two counters. One is TX counter, one is RX counter. Okay, so every ECU which are connected to the ECU will be having TX counter and RX counter. So what happens when there is a, now assume this is the ECU A which is sent the acknowledgement error or any other error, whatever the error we have discussed so far, any error is on the, which is active on the bus. That time if the error message sent one time, the TX will be the TX counter which is a TXC you can consider, otherwise TEC we call it as, REC we call it as receiver counter. TEC means transmitter error counter, receiver error counter. TEC, REC, transmitter receiver counter, receiver error counter. So the TEC will be incremented by 8 times. Then nothing but the counter will increment to 8 for the first error message, and REC will incremented by 1. Okay, so assume the acknowledgement error again sent twice. What happens? It will increment by 8. What happens? 8 plus 8? 16. So similarly, if it is sending third time, fourth time, fifth time, sixth time, seventh time, however, it cannot send forever because it is avoiding the communication of the all other ECUs which are connected to the ECU. So when the TEC counter reaches 127 equal to or greater than 127, the active error which is called acknowledgement error which is present now will become the passive error. So what does it mean by passive error? All other ECUs which were not communicating because of the active error, all other ECUs will not bother about this active error and will start communicating each other because this error has been converted into passive error. How it is converted into passive error? When the TEC is greater than or equal to 127. TEC or REC. Usually it will be TEC because TEC increments by 8 counts. REC increments by 1 count. Clear how that active error converted into passive error?
Yeah.
Okay, so let's say now the error is converted into passive error which didn't create the problem between the all other ECUs because it is started, all other ECUs are working fine, all other ECUs are communicating fine. So now let's say the counter will be keep on incrementing after the 127 because still even though it is a passive error it is still on the bus. Okay, even though this passive error will not be bothering or will not be all other ECUs are not bothered about this particular passive error, it's still on the bus. Once the counter of TEC in reached 255, that's where the bus off condition occurs, where this complete node will be removed on the network. Okay, and one of the use of the canoe here is there is no dependency on the hardware because everything is about the software which you deploy inside the CAN transceiver, CAN controller and the ECU. If this ECU is not working, you will just simply ignore this, nothing but remove and throw it and add another ECU and just simply flash the software of the CAN transceiver, nothing but every level. There are different layers in the software development cycle. I hope you guys are already aware. So all those softwares will be flashed inside the this hardware. So that is the reason the use of one of the use of CAN protocol is also it is not in it is a independent of hardware because there is no particular address for this hardware. The address what we have is identifier which will be defined in the software, not on the hardware. Okay, so once it is reached more than or equal to 255, the bus off condition occurs where the hardware will be getting removed on the bus. Okay, so how do you think the counters will get decrement? So let's assume the one of this ECU. Now this ECU will consider has been transmitted the uh, CRC error twice, and then there could be some system reset inside of the software and it is working fine now. So now the TEC will be 16 and REC will be 2. So of course it was the active error. It was not allowed any other ECU to communicate each other. And then since the CRC error removed due to the system reset inside the software, it is working fine. So ECUs are transmitting the data, nothing but ECUs are communicating now. So what happens if the ECUs are especially this counter where it has the TEC as 16 and REC as 2, what happens for this? What do you think should happen? It will decrement for the first message successfully sent. Okay, so there was a error. So the TEC error counter incremented by 8. Again there was a CRC error, TEC error incremented by 116. And then due to some of the system reset, or it could be the because of the watchdog, because of anything. So the ECUs has started communicating, the whatever the ECU was sending the error message started sending the positive data frame. So that times this error TEC and REC counters, error counters will decremented by 1, not by 8. Both the TEC and REC will be decremented by 1 based on the successful transmission of the message. Clear?
Yeah, clear.
Okay. That is what is all this. Then what else we have? Synchronization. Bit stuffing. This is why synchronization we have discussed. Here it is the bit stuffing. So this is the example. So as you can see here in the example 1, there are continuous dominant bits. So where we will stuff the recessive bit, and then it keeps on. It continues since there is no continuous. Nothing but there is no voltage. I mean, voltage is fluctuating usually. There is no. It's not constant every time. And then in the example 2. So once after the fifth one, again there is already a recessive, so it has stuffed the recessive and it has carried the recessive bits. Even though if you can see here, it is having a 5 bits of the same polarity, and it's the job of CAN transceiver to stuff the recessive bit after the 5 same positive bits, after the consecutive same positive bit. So that is the reason it has stuffed the recessive and then carried the already present data. Okay, you don't have to confuse. Okay, after the 5, it is the data itself is the recessive and it should not do the stuff. That time it will create the bit stuffing error. The standard says it has to stuff after the 5 consecutive bits with the same polarity. Same over here also. Okay, once you stuff it, so it has become 1, 2, 3, 4, 5. So what happens? It requires another stuff of dominant bit because it is the continuous 5 recessive bits with the same polarity, which is a recessive. Understood? Hello?
Yeah,
Yes,
understood.
ma'am.
Okay. So one thing to confirm here, whatever the we are stuffing the data, 1 or 0, dominant or recessive, whatever we are stuffing, that is not the actual data. That is not the information. So it will be destuffed once it is received by the receiver. The actual data is what is their actual data. Whatever is stuffing, that is only to maintain the all the ECs in the synchronization. That's it. There is no another other um, use of it. This is a dummy stuffing bit which will be destuffed by the receiver once the data is received, because it does not contain any information. The information contains only in the other bits, not on the stuffed bit. Okay.
Yeah.
Yes.
Okay. So the next is we have discussed the synchronization. But anyway, how exactly, this also we have discussed. So whenever you are stuffing the bit, what is happening? You are creating the fluctuation over there. So this that is kind of a resynchronization which you are doing. So first of all, you are doing for the purpose of having the like to have all the nodes in the sync. So that is the reason you are doing the bit stuffing. So the first sync will be done by the start of the frame. That is called a hard sync, hard synchronization. So in the start of the frame, what happens? It does the synchronization of every ECU. So that is not sufficient to send, to have the every ECU in the to have the every ECU in the sync. That is the reason we have this bit stuffing concept to perform, to make every ECU, to have every ECU in the synchronization. Okay, so what else I have? This is not required on these things. I think I have opened the wrong one. Did I share the same? I shared completely. Yeah? Hmm. Okay, the construction of every bit and its timing, it's not required. It's not for you guys. Okay, so that's it. Okay, since we can have half an hour more, so errors is done, error detection is done, arbitration is done, frames are done. Okay, so we were discussing about the feature. So we have discussed the master. By now you should be able to understand. So, and we have discussed the speed also, where it provides the up to 1 megabits per second, but we usually use 500 kilobits per second in practically. And now I'll read the feature and you guys have to tell me what is that feature. allows 0 to 8 bytes of user data per message. What does it mean?
For every message, it allow only 0 to 8 bytes only.
In the data field. That is what is important here. You can send the actual data of 8 bytes in a single frame. Okay, that's what it meant by. So puts multiple transmitter receive message boxes at each node and assign each an identifier. So what does it mean?
To send the data to a particular node, identifier
Mhm.
is required.
Very good. So here, as I have already showed in another PPT, acceptance criteria. So the use of identifier, we have discussed two uses of identifier. One is to identify which is the input, another one is to provide the, to perform the arbitrarization. Using that input only, acceptance criteria will be developed from you guys based on the requirement. So let's see how the requirement looks like. How exactly you develop the can frames. As I said, you will be doing only on the application layer, but let's see how the requirements looks like. So it is same for the requirement which I am going to show. It is same for the testers and the developers. So you will, both of them will be referring to the same requirement, but you will be developing it. So testers will be testing it. That's it. Let me take one of the frame. See, this is how you will get the module TX and RX messages. So you should know what is TX messages meaning and what is RX messages meaning. And for every TX and every signal or every frame will be identified as a TX and RX. See TX messages. Yeah, this is one of the message. ODS 01000 millisecond message. This is the just a name. But what is important here? What is important?
Value hexadecimal value.
Identifier meaning. This is the identifier.
Yeah.
Okay. So if this is this identifier, nothing but a frame identifier is a transmission message, which is a TX message, meaning what? Is this output from the ECU or input to the ECU?
Output from
Output.
these.
Very good. In practically is the output from the ECU. But when you work on the CANOE, since it is a virtual, it will be opposite. You can see the direction as RX, not the TX. Okay. So in this frame, you have a multiple signals. When we say signals, meaning what? These are all data. What exactly you configure in the software, how the ECU has to provide the output data. Nothing but what is it? What is that? So you will write a one function and you will return the value from that one function. That return value will come and sit in this signal. So if this that value return value which is coming under and sitting over here, if that is 0, which means what? If that is 1 means what? That is what the requirement says. Let me take an example, like anyway CRC I am not taking. I will take the example of ID val. Otherwise ODS OCC class status. Let's go to this signal. So when I am saying signal meaning, where is that frame structure? Yeah, meaning you can see the 8 bytes of data what you can send in the data field, right? Every byte is a signal. That is what you are having here. One byte is this, one byte is this, one byte is this, one byte is this. Every byte is a signal. So in CAN, we will be having a 8 signals if it supports complete 8 bytes of data. If not, it will be having a default values like 00 or FF or 11. So here it is CAN FD. That is the reason you can say DLC as 16. So don't get confused. Okay. So in CAN, it supports only 8 bytes of data to send on that particular data field. So these are all the signals. Nothing but number of bytes have been identified for every, like in that particular 8 bytes of date, you can configure 2 bytes for the one signal, 2 bytes for the one signal. Depends on the project. So now if I consider the ODS OCC class status, let me go to that particular signal. See here, that signal contains how many bits? Complete 1 byte only, not more than that. 32, 33, 34, 35, 36, 37, 38, 39 bit completely, which is a 1 byte of data. So if it is a 1 byte of data, how many values you can generate? Hello? How many? This is the what signal we were discussing, which we have seen. It is a 1 byte of data. So when you get the signal, every information will be present on the requirement, where you have to understand why this frame is for and why this exactly signal is for. Give me a second, guys. Yeah. Why exactly this signal is for and what is the timeout? Nothing but what does it mean, the timeout? What does it mean by the periodicity? Anybody knows what does it mean by the periodicity?
Particular time.
Particular time means what?
Yeah.
You know,
Sorry?
how much
Time
time,
to
time taken
time to
requires.
exit time to
No,
exit the transmission.
not time to execute the transmission. Periodicity
Exit
meaning
exit.
how often you ECU has to output this frame. Okay, here there is no periodicity. You can see only the timeout. I'll come back to the timeout. I asked about periodicity. See, message type is periodic. Output period is 1000 millisecond, which is 1 second. Meaning what? So this you guys are already know it is a TX frame, which you have seen it. So nothing but ECU is transmitting this message. Nothing but ECU is providing this as a output. So how often ECU has to provide this output? That is what is periodicity meaning. This is how you will see the requirement, and this is how you have to understand. If you understand what does it meaning, then only you can just simply configure 1 second in your configuration, in your developed code, or which you are going to develop. Clear?
Yeah.
Yeah. So I can see something called message timeout. So what do you think? What is message timeout?
Same time requirement to receive or send a message time to ECU.
To ECU? Can you please come again?
Requirement of time, okay, to receive the message or
No, this is a transmission message, right? As per the developer, see, you guys will be working on only one system. So if you are checking the system, you will check the output only. You will not check whether that output is received or not received. It doesn't matter for you. So whoever is, if this output from your ECU is received or not received is, that will be a RX for the person who is testing on that particular another system. If you are working on the brake system now, this is the output from the brake ECU. You will check whether it is providing the proper output or not. You will not check whether other ECU is received or not. You will be checking only one ECU, not the another ECU. Getting my point? In like once you get into the job, this is how it will be. You work on only one ECU, not on multiple ECUs.
okay.
So here message timeout is nothing but if the ECU is not output, like here it says it has to output the message every 1 second. So maximum it can wait for 5 second. If it is not providing the output, then something wrong. It will start, there it will move to the safety version. There will be a safety people, like, sorry, not people. So there will be a safety versions for the every system. Okay, so it will get into that mode, safety mode. I mean, depends on the project also what they want to do after the timeout. But yeah, this is how you have to understand every signal and what does it mean by it. Then only you can test, or then only you can develop it. So we were discussing on one signal, which is, which one we were discussing? OCS, right? This one. Okay, so there is no timeout for this particular signal, but this is one of the signal in a one complete frame, and we have seen the periodicity and the timeout for this particular frame. Okay. And then you can see the value 1 2 4 when this particular bit is, how this particular, this is a 1 byte value, nothing but like this it looks like. So if it is 01, what is the value? If it is 02, what is the value? If it is 03, what is the value? If it is 04, what is the value? So who configure this? As a developer, you will be having one of the function. So let's take it's something like a pressure sensor, and the return value will be like, if the pressure is this much to this much, it will provide one of the return value. So that return value will be coding inside this variable, which in the can signal it will say 01 or 02 or 03 based on your our return value from one of your function. That typically depends on your project. So this is how you configure it. But as a tester, when you see 01, you will understand what is that meaning. That is meaning it is empty or child. What is 2 meaning? It's adult. What is 4 meaning? It is faulty or indeterminate. So as a developer, you have to, if case of this value, one particular variable x1 value is equal to 1, then classify that as a class 1. If you do this, then only tester can identify this is what, I mean, the software has been developed as expected, nothing but as per the requirement. If not, it is a bug. They will create a bug by showing this requirement. Requirement says the output from the can signal, if it is a 1, it should be a nothing but it should be empty or child, but it's showing as a adult. Then that is a bug. Nothing but developer has not developed properly as per the requirement. Clear?
Yeah, one doubt.
Yeah,
Uh,
please.
how are these signal names written like
It's
ODS?
typically based on the project. It keeps on changing. That is the reason the name doesn't matter here. What does it matter? I mean, once you get into the project, you will be having this complete document which has been written by the system engineers. So for system engineers, they will be getting from the clients. So client will be providing the signal name. So they will just, system engineer will be rewriting, or give you the small values or the names which they will be writing in the requirement. So as a developer, you will not be using the complete exactly this name. You will be following your own standard to develop the codes, which is the, like, you guys have to use the misra coding if you are becoming an embedded developer. If you are going to be AutoSAR developer, you have to use the AutoSAR, so where there will be already names present. Okay, so there will be a mapping. So you will, whenever you see this signal, you will go to the AutoSAR standard and check the name for that this particular signal and use it. How you have to use it.
Yeah, okay.
Okay. So for the testers, they will not be concerned about the name. They are concerned about the IDs, the numbers. Okay. Okay. So what next? So any other doubts so far? Let us see, did I miss anything? No, can, these things are not required. Okay, so this one I'll explain. It might be useful for you guys. Okay, so if someone is asking what is bit time, or whenever you are checking how much is the time it's taken by the your code or by the ECU to transmit one particular bit, that is called a bit time. So where we know what is the data rate for the CAN protocol. What's the data rate?
500 kbps.
In practically, we uses 500 kbps. It can use we can use up to 1 megabits per second, but in practically we uses 500 kbps. So to transmit the data, if it is using 500 kbps, then what is the time required to send one particular bit? To the calculation fast. I'm asking for one bit. You can send 500 kilobits
500
for 1
kilobits.
second.
Hey,
Then
hey, hey.
500 millisecond, right?
Sorry, how much?
500, 5000 millisecond, I think.
Yes, you are sending 5,000 for 1 second. How much time is you required to send one particular bit? You are sending here is like some 50 lakhs bits per 1 second. I'm asking for one bit. Here you are sending these many bits for 1 second, in within 1 second.
5 lakh millisecond.
It is 2 microseconds which you require to send the one particular bit. Okay, so this is called a bit time. The time taken to send one particular bit. Okay, and all this configuration you guys have to do in the Kenoi. Clear?
Yeah.
Then what else? What else on this is not required? Okay, anyway, I have explained one signal and one frame. That would be enough. But one information what I can give is please understand before you do anything. Okay, so since you guys have not worked before on all these things, the names, the words which they use, you may not be aware of it. Okay, so you have to understand when they meaning when if you don't know one word, just try to understand from others and then try to develop or to test it. If you miss, then it will become a bug. If someone is not identifying, it will become an escape. What is an escape meaning? Anyone has already explained the process?
No.
Okay. So escape meaning if you are a developer and you missed something, one requirement, then it will go to the unit testing. Anyone explained what is unit testing, integration testing?
No, but I know what is unit testing.
Okay. So if it is not identified by the unit testing and integration testing and even by the system testing, assume it has been identified in the vehicle testing. So if that comes to you, then that like anyway it will not come directly to you, to the developer. It will come to the tester first, which is in the name of escape. So they have to perform the 5 analysis why they have missed it, why they couldn't identify the bug. Then it will come to the developer where you have to do the 5 analysis. How come this has missed? Why didn't you understand the requirement properly? Why didn't you review the your developed code with the your code whenever whatever you develop, it has to undergo through the review process. where your coworker could review based on, companies, it varies whether your lead will review or your manager, or there will be a one person called a expert for that particular module. He has to review. Then at the end, it will come on every head who has not done the review properly. So you guys have to do the 5 analysis. Why it has missed at the end. Okay. So which will leads to the customer satisfaction to the low level. That is what is an escape. So to avoid that, understand what you are going to up, even though there is a small change in your code, understand why are you doing that, why are you doing in that way, why not in another way, why exactly you are doing that. Okay, so understand the requirement and then do it. Okay, fine, then I have that much from my side. If you guys have any doubts, please go ahead. If not, we can end the session. Then we will start the UDS tomorrow or from Friday.
Yeah, okay.
Any doubts? No doubts?
Mm,
Nobody has anything to, I mean, no doubts. I mean, it should not be on